Okay, I'm having a look at a question that looks at confidence intervals within a binomial scenario. So we're used to doing our confidence intervals mostly with our normal distribution type questions, but this one's a little bit different because it's using our binomial, so I thought that would be a good one to have a look at. We've got a scenario where there's research happening and 8 fish are caught each day from a lake. They think that 63% are trout. So the first one just described is where you want to describe the situation. So we've got 8 being caught each day, 63% thought to be trout. We don't have standard deviation or mean other than the 63%. So that is leading us to our binomial distribution, and we're obviously looking at if it's trout or not trout. Our number of trials we are doing each day is 8 because that's how many fish are being caught. So we can be saying that our n equals 8 and our p is going to equal 0.63. That's about all we needed to do for that part of it. Then it has over 14 days, how many times would you expect the daily catch to contain more trout than other fish? So if you've got 8, if you've got more trout than the other fish, then you need to have at least 5 trout. So 5 or more would give you more trout than other fish. So we want the probability to start with of getting that more than 5. Now we're working with our binomial, so we can't do on our calculators the greater than 5. So we want the value that x is greater than 5. So we're going to have to do 1 minus the probability that the x is less than or equal to 4. Because we're dealing with the whole numbers, then we're looking at the 4 and we're doing the 1 takeaway to get that opposite scenario. So we can grab our calculators and use our binom CDF because that's the one that is the cumulative. It's adding up to that point. So we're going to tell it we've got our 8 trials. Our probability that we have is 0.63. We're putting in that x value of 4, and then we are working out that answer to be 0.3374. So we're going to do 1 minus 0.3374 for that, and we get 0.6625. That gives us that probability each day that you're going to get more than 5 or more fish, 5 or more trout. We want to know over 14 days, so we just multiply that by 14. And that will give us 9.27. So we'll say that's approximately 9 days that you will have greater than or equal to 5 trout that are caught. In the next one is one where we've got determine the probability that a total of 15 trout are caught over 2 consecutive days. So we want to look at what combinations will give us 15. Now we've got our 7 and 8. That's going to equal 15. Now, obviously, we could do 5 and 10, 6 and 9, etc., but we can only get a maximum of 8. So that limits us to 7 and 8, so 7 on one day, 8 on the next, or 8 on the first day, 7 on the next. So that's 2 different combinations that will give us that. Now, we know when we are doing our probability of, so this one would be 7 on the first day and 8 on the second, so that's our AND rule. So we're going to multiply our probability of 7, and we're going to multiply that by the probability of 8, or x equals 7, x equals 8. So we can work out those probabilities using our calculator, and that's where we'll then use the PDF because we want exactly 7 or exactly 8. So we go to our binom PDF, and our number of trials is 8. Our probability is 0.63, like we did before. Our x value, we'll do the first one is 7. And we get 0.116, and we can round that up to 66. And then we can come back here and just bring that back down and just change that one to an 8, or we can go back into that binom PDF again, and we get 0.0248. And so we're going to want to do our 2 times that answer, and then we're going to multiply it by the other answer as well. So we get 0.00578, which we can round to 0.0058. So that gives us that probability that you're going to get that 15 caught over the 2 consecutive days. In the second part of the question, it's then brings in that there was a suspicion that the proportion of trout was actually lower than the 0.63, but greater than 50%. So we're being asked to calculate a 90% confidence interval for the proportion of trout, given that 48 trout were caught in a 10-day period. So now we're going to go, okay, well, out of that, in the 10-day period with 8 per day, 10 times 8 is 80, we got 48 out of the 80 were trout. And so we're going to use that as our sample proportion, and we get 0.6. So that gives us that sample proportion. And then we have obviously got our n is equal to 80. And we are going to want to find out that confidence interval for that scenario. We want 90%, so we know that the z-score for that is 1.64. So we're going to do that 0.6 plus or minus the square root of 0.6 outside of, 1 take 0.6 over 80. And then, oh, and I forgot my 1.64 out the front there. So when we do that and put that into our calculator, we will get 0.51 and 0.689 as that interval that we have there. Then we'll go on to the last part of the question, which is saying use the confidence interval to comment on that suspicion that it is greater than 50% but lower than 0.63. So that's where we would go, well, the 50% isn't in that confidence interval, so it's probably not as low as that, but the 63% that we were thinking it was does lie in that confidence interval, so we can say that that is within there, but there is that evidence that it's more than 50%. So that part is right because the 50% doesn't lie in that confidence interval there. So we're able to make that comment there about the 63 being in the interval and the 50% not being in the interval.